Chapter 6, Section 4, this is functions, apprentice level. What is a function? Well, let's put mathematics aside for a second and just think of an example. A machine, okay? We build machines, they have a purpose, they have some sort of function. There's something that we want them to do for us. So in this picture I have an old-fashioned coffee grinder. So the coffee beans would go in the top or in the back, and you would grind them, and then the coffee grounds would come out at the bottom of this little drawer. So that's what this simple machine was designed to do. So what is the function of a coffee grinder? To grind coffee. That's what it's meant to do. It doesn't do your laundry. It doesn't drive your car for you. Okay, it doesn't help you with your homework. It grinds coffee. Okay, that's its function, that is its purpose. All right? What is the domain of coffee grinder? Well, we think about domain, those are the x values. Those are the independent numbers. Those are all the values that we can choose. So with the coffee grinder, the domain is what can go into the machine. Okay? Well, coffee beans. That's the input. The domain is coffee beans. Okay? You don't put in water. Okay? You don't put in a shirt. Okay? Those things are not in the domain of coffee grinder. So the things that go in are the coffee beans. What is the range of a coffee grinder? Well, assuming it works properly, it's what comes out. It's the output. So in this case, it's coffee grounds. Okay? That's the only thing that's in the range. All right? You're not going to put in coffee beans, okay, and then work the machine, and then suddenly jelly beans come out. Okay? Those are not in the range. Okay? So coffee grounds, that's what's in the range of the coffee grinder. So next it says list two things not in the domain of coffee grinder. So I've already listed a couple. Clothes. Okay. That's not in the domain. That's not something that goes in. Clothes, and I think the other one I said was water. You put that in, that's one way to wreck it, or make it rust. And list two things that are not in the range. So what are two things that the coffee grinder will not give you? Okay, given its domain, which is coffee beans, okay, you're not going to get a car. A car is not going to magically pop out of your coffee grinder. And what else? For you Star Wars fans out there, I'm sorry, but if you work your coffee grinder, Luke Skywalker is not going to come out. Sorry. All right, so let's talk about something called a function. Once we know what that is, then we can compare that to, well, just a plain good old relation. So just to give you an idea, let's just pick the number, I don't know, 5. Okay, and that number 5, I'm going to put it into some kind of mathematical machine. So it's like it's on a conveyor belt. Okay, and inside this machine, the machine will subtract 3 from the number 5. It'll subtract 3 from any number that you give it. That's all that machine is designed to do. So once the number comes out of the other side, of course, the number 2 should come out. So 5 is in the domain, 2 is in the range. This was the input, that was the output. Well, this is an example of a function because when 5 goes in, there's only one number that can come out, right? It wouldn't make sense to say you put in 5 and you take away 3 and the answer is 4. Okay, you know that doesn't make sense. That's not true. Okay, so this is an example of a function. This is an x value. That's a y value. So if I was to plot this on a graph, this would be the point that I would plot. Okay, so whenever x is 5, y is always 2. It can't be anything else. But if I was to have a relation where x was 5 and y was 2, But then there was another point where x was 5, but y was 8. Okay, they're two perfectly valid points, but that contradicts the notion that this is a function, because if we put in 5, the only y value we can get is 2. We can't get two different y values for the same x value. So in a nutshell, that is what distinguishes a function from just a plain relation. So I'm actually going to summarize that right on the bottom. For each x value, there exists only one unique y value. If that condition is satisfied, then the relation is special, and we call it a function. All right. So let's look at how can we test to see if a relation is a function if we have a picture, just by looking at it. So you don't need to calculate anything or do any algebra or anything like that. You just look at the picture and you can tell right away. So we have 4 pictures down here. Okay, and this is the test that I'm going to take you through right now. So here's how we test. Place your pencil vertically on the edge of the graph. Right, so for example, I don't know, here's your pencil, the tip. There's a lining, and there's your eraser, I don't know. There's your pencil. Just place it like that on the left vertically. That's step 1. That was pretty easy. Now step 2. Slide, do it slowly, slide your pencil across the graph from left to right. So keep the pencil vertical, and you're just going to slide it this way until you get to the end. Okay, that's step 2. Pretty easy. Here's what you just have to watch out for. Okay, if at any time during your journey, if your pencil crosses the relation, that's this curve, more than once at any point, it's not a function. Okay, so I'm going to imagine my pencil at any given point is just this red vertical line. So maybe it was here. Okay, so you can see it intersects the graph right here. Okay, well, there's only one point. Okay, there aren't multiple points up here, 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 here. So that's okay if I moved it here. Okay, how many times does my pencil cross this curve? Only once. Same here. Same here. Same here. So in fact, anywhere along this relation, my pencil is only going to cross over once. That's good, because that means this is a function. So any x value that's used can only produce one unique y value. All right, let's look at the next relation. We have a circle, but we want to apply the same test. So just put your pencil vertically here and slide it horizontally. But you'll notice that once you start touching the circle, okay, it crosses the circle twice. Okay, in fact, it hits the circle twice everywhere, with the exception of the endpoints. Okay, well, twice is more than once. Okay, so this is not a function. It's just a, all of these are relations, but this is not special. So we would say, this thing will write, not a function. Okay. Because if you choose, I don't know, x equals 3, and look at where the coordinate is, well, you have a y value up here, but you also have one down here. So you have multiple y values for a single x value. And for a function, that is not allowed. All right, next one. I mean, once you catch on, this is pretty easy. All right, so moving from left to right, well, I think that's easy to see no matter where I go on this line segment, or actually it's a ray. Okay, it's only going to touch it once. So every specific x value can only produce one y value. So this passes our test. So that's a function. Okay. And I would imagine you can tell already that this one is not a function. Okay. Why? Because when we apply our test, well, maybe it satisfies it here right at the far end point, just touches it once, but everywhere else Okay, my pencil will cross over my relation more than once, so it's not a function. So all of these are relations, but only the first and the third one is a function. And to finish off, the test that we've been applying here actually has a name, and it is called the vertical line test. It's nothing formal, but it's pretty easy to understand.